Hi everyone, I hope you're all doing well today. Today we're going to talk about graphing rational functions with holes. If a rational function has the same factor, x minus b, in both the numerator and denominator, then there's a hole in the graph at the point where x is equal to b, unless x equals b is a vertical asymptote of the function. The way we graph these functions is first by factoring the numerator and the denominator. When I factor 4x squared minus 9, I notice it's a difference of squares, so it would factor into 2x plus 3 times 2x minus 3. Now my denominator is also 2x minus 3. Therefore, I have the same factor of 2x minus 3 in both the numerator and the denominator. So I can use that to help me find my hole. I'm going to take the 2x minus 3, set it equal to 0, and solve for x to get my value of b. So x is equal to 3/2, which means there's a hole in my graph at 3/2. When I graph my function, I'm going to cross out the common factor in both of them and graph the remaining function. So I'm going to graph the line 2x plus 3, but I'm going to leave a hole in it at the point where x is equal to 3/2. So looking at my function, my y-intercept is 3. I go up 2 and over 1 to plot my points. Now, at the point x equals 1/2, we said there was a hole. To show there's a hole, I'm going to leave an open circle at that point. I'm going to connect all of my points to draw my line, but leave the open circle to denote the hole in the function at that point. Please take a moment to pause this video and record down the example. Before you try practicing on your own, I'd like to do one more example together. So let's take a look at the function f of x equals the quantity of x cubed plus 2x over the quantity of x squared plus 3x plus 2. Again, to determine where my hole is, I need to factor both the numerator and the denominator. Looking at my numerator of x cubed plus 2x, they both have a common factor of x, so I would pull that out and get x times quantity of x plus 2. Looking at my denominator, x squared plus 3x plus 2, it factors into x plus 1 times x plus 2. I notice that I have a common factor of x plus 2 in both of them. So I'm going to take my equation x plus 2 and set it equal to 0 and solve to find where my hole is. So my hole is at the point where, at the value on the graph where x is equal to -2. When I cancel out the common factor of x plus 2, I'm left with the function of x over x plus 1. Now this is a rational function. My x-intercept would be at 0, the real 0 of the numerator, and looking at my denominator of x plus 1, I know that there is a vertical asymptote at x equals -1. So I'm going to draw in my vertical asymptote, and then I'm going to find and plot points on both sides of the function. So let's see, if I plug in 0, I would have 0 over 1, which is 0, my x-intercept. When I plug in 1, I have 1/2. When I plug in 2, I get 2 over 2, which is 1. And I can connect my points, getting close to, but not going over my asymptote. And let's see, if I plug in the value of -2, remember there's a hole there. When I plugged in -2, I would get -2 over -1, which is -2. So I'm going to go to -2, -2, and when I put my point, I'm going to leave it as an open circle to represent the hole. When I plug in -3, we'd have -3 over -2, or negative 1.5. And when I plug in negative 4, I get negative 4 over negative 3, so negative 1 1/3. And I connect my points going close to and approaching my asymptote, but not crossing it. And that would be the graph of my function of f of x. Please take a moment to pause this video and record this example. Also, write down any questions that you may have on this concept for when we have our next Zoom meeting. See you soon.